Alright guys, been out here working on this a lot and just actually pretty much finished up this first control board. So, I don't remember quite what I did on the previous part, but just going along as I'm going along here. So, here it is. You've got 12 volt power supply here. Variac control relays because I did not get double pull, double throw switches, so I had to substitute in relays for single pull, double throw switches. So I had to use some relays to be able to get the double pull, double throw action. Over here we got the final control. So basically this will not allow power to go to any of the final contactors until you actually turn on the final output, which is these 4 relays here. So what happens is this is a cut relay, so if I want an e-stop or something, or no, this one of these, I think it's this guy or this guy right here. It's actually only 3 relays. Yeah, I did it in 3 relays, sorry. So this is a cut relay down here. So if I apply power to that pin right there, it will actually cut out the final. So for an e-stop or whatever, that's what that's for. I don't have that implemented yet, but it will be implemented soon. Power comes out here to the contacts for the switches. You got this relay here, which what it does is this will be able to latch the final one. So you can see these wires come in here. So this loop here, and then there's a loop here, from here over to there, or from here down to the coil. So what happens is if you have this one latched, when you press the on button for the over there, the on button just turns on the coil. What will happen is, because there is plus 12 volts over here, or actually right here on this wiper, because of the normally closed switch. So what happens is if this is latched, if this one's latched, the power can actually come back through and latch this relay. But if this one's not latched, so this connection between the wiper and the contact, and then also the coil down here, if that's not made up, then what happens is it's only momentary, and then that output comes over here and triggers the final. So that's the rough idea of how that works. Over here, so let's see, I got my bearings. This is the ballasting control, so cut for the ballast, latching relay for the ballast, and ballast control relay for all that, so that will activate that contactor. And then you got all the ballasting contactor control relays, so 1 for 1, 2 for 2, or over here, 1 for 1, 2, 2, 3, 3, 4, 4, 5, 5. So 5 is actually the auxiliary, so if you notice it's on the normally closed side, so that it's always shorted out unless you want the auxiliary, and then it will be passing through there. So that's how all that is set up. Quite a bit of wire that needs to be ran. All this needs to be made up neatly, and then there's all of that in there that still needs to go to over there. So that's my plan for today, is to work on that. It's already like 6:07, 6:08 now. So yeah, all this was neat, but then I added this in. And I think what I'm going to do is actually not do all the lighting up here. I'm actually going to do it over there, and I'm going to take some of these off and put it over on that one just to make the wiring neater. So there's the power supply. You can see the neutral for the contactors there. Neutral coming down, mains coming in, mains actually coming over, and going to the first contact, which is the ballasting. I think it goes ballasting, 120, 240, 480. It won't be those voltages present. What it'll be is 120 volts, 120 volts, 240, then 120 volts, which I may redo that eventually, just because it is just a relay in there. So if I need to, I can add contact spacers in there, but they're already actually, I'm looking at the inside and there already is contact spacing, so I should be fine, should be completely fine. So I'm not going to give a demo yet. I'll give a demo when I actually get everything done, just because I like to save for the build-up. So I'm actually going to get to work on finishing, neatening up all these wires, and then I'll get back to you guys once I got that done. As you can see, I got a little bit excited and went ahead and just put everything in, or put that up in there. So that's how it's going to mount. Yeah, there's a bit of a rat's nest in there, but that's all the service loops. It's not really a rat's nest, they're all coiled up. It looks like they're all sticking out, but they're actually all coiled up right in there. So those may be an issue, and I may have to go with some type of flat screw in there just so the door still closes, or I can notch the door right there, which will be fine too. So basically there's a self-tapper on each side right there, grabbing into this lip. So it grabs in that lip, and then the bottom lip I'm actually just going to have rest on this board, because it's actually a piece of wood, but it's it's particle board, but it's a really sturdy particle board. It's designed for weight. So I'm going to let the backside rest onto there. So if you see, if I move this up, I don't know if you can tell, but that entire top board is moving. So right now I'm kind of sorting out wires. So this is the up signal for the Variac. So you can see those all will go down into there. So yeah, I probably actually got more wires than what I really need, but oh well. I'm just gonna, I think actually I start like right here and go over. So wherever it is, I got everything nice and laid out in that book right there, and I redid everything in there. So yeah, so that's how all that's gonna look back up in there. I just retested it when I pushed everything, and I knew everything would be fine, but I just tested it just in case, and it still works just fine. So now I'm going to go through and do that. So like stuff like this, it's going to go over there. I'll put some sticky feet across there and run it across. These are the ballast control wires. So the number 6 here, and I didn't have any more number 6. I had to go to number 4, which, oh well, gives me 100 amps. Number 6 will give you 100 amps under a short distance, and if it's high temperature rated, which this isn't. So I'm not supposed to put more than 60 or 70 amps in here in enclosed space, but oh well. And then like number 10, I'm not supposed to put more than 30 amps in there in an enclosed space. Open air, you get a little bit more, but so those will go there, and those will go down to all the different stuff that's going to be down there. But I'm laying it flat so I can set everything in there and run all the wires. So I'm going to move some wires, get some sticky feet in there, and try to organize all the wires over. And I'll get back to you guys when I got to that point. Alright, I've been doing a little bit of tidying up. You can see those all over there. So that's the Variac and 480 systems. So that relay group and that relay group are all over on that side. Because those are the terminal blocks it uses us there and here, and so those go there, and I'm gonna do the rest of these over on top of there. So this is the the output view, so it switches between before the contactors on one leg, so it's just only switching one leg because one leg is going straight through. So hot 1 will be always carried straight through. Then we'll select between neutral or hot 2 and hot, and it's hot 1 that we're actually putting through the Variac. So the hot 1 goes through the Variac, then out, and so man, I'm been grasping for straws for some reason. I know exactly how this is in my head, but I can't speak it. So we need to measure before the Variac, so we have the main side, and so 1 voltmeter will be on the main side before the Variac and everything, and then on the other side, on the hot 2, which is the side on hot 1, which will be going through the Variac, then through the contactors will be the next meter. But we want to see before that contactor what that voltage is, so we need to skip it ahead. And then what we're due to change the actual output voltage scale that we want. So if we go from hot 1 to neutral, we get 0 to 130. I'm just going to say 120 for now. I'm not worried about the overturns you get. And then from hot 1 to hot 2, we get 0 to 240. And then from hot 1 to X1, I'm calling it, which is the 480 line, you get upwards of 480. Because we're going from one part of the tap, just a little bit up on there, and the rest is overturned. So that's how that works. So I was thinking of a way of maybe implementing the ballasting circuit into just the overall usage of it, but just to make things simpler, I'm not, because besides the contactors I'm working with here, because then I would have to make a specific circuit so that if it was on 240 volt line, there would be no possibility of a ballasting circuit, just due to the fact of you'd be running possibly 200 amps through a 50 amp contactor and through number 10 or 6 wire. So I know it's a bit of a talk on this one, and I'm talking a lot like I do in a lot of videos, but I try to give you guys as much detail as I can. and try to get what's, all the ideas of this out of my head and onto here, which also gives me a reference later to look back. So I'm gonna go up and eat dinner because it's 7 o'clock and last time I ate was 11. So I'm hungry. So those are all those circuits, and then the rest of these are still gonna be tidied up. Down here we got some of the mains, or not mains. This is a ground wire, and then we got the voltage going into all the relays, and then we got the main voltage coming from the power supply, because that has to go through those 5 right there, those main contactors. We have cut circuit here, so this will cut the ballast. Any one of these will cut all the other ones, and this purple wire, so the orange ones will cut the other 120, 240, 480 volt relays. So those will go after the diodes, so I can just turn off those relays, and this one will trigger, so whenever one of those turns on, it will put power onto this one, and it will turn off the ballasting control. So that's how that one works. And then all this is just, more wires. So that's the key switch, and there's going to be a bundle in there for main, and this is the mains. So 120 volts goes into there, so this will go between hot 1 and neutral, and then I'll bring the power through a connector from the variac stack. Or actually, no, I decided I'm redoing this. So the power is going to go into here, and then a connector out to the variac stack, because then I just need 4 connections, and then from there it's going to go back and then through the contactors and everything. So that's about that. And so the next video will be the project of tidying all this up and connecting all of those in, and then after that should be getting the contactors in, and then after that will be all the plugs, and then I gotta order the stuff to finish up the variac stack, because I gotta do a pretty heavily geared motor, because those variacs are very difficult to turn. I actually have to lean into it when I'm trying to just grab the top of the variac and spin it around. It needs like 30 to 40 pounds of force, and I can't just grab that 3/4 inch shaft and twist it by hand. It's that difficult. So yeah, so that's how this is going to be going. I'm excited to get this done. This thing is going to weigh quite a bit, already does, but I think it's going to be nice and neat seeing all of that come into play. So I'll see you guys in the next video, and hope you guys are enjoying this series as much as I am. See you later.